A particle moves in the xy plane so that at any time t greater than or equal to 0, the position of the particle is given by x of t equals 2t cubed minus 5t squared plus 36t plus 5, and y of t equals t cubed minus 3t squared plus 1. For what values of t is the particle at rest? So what we know about a particle being at rest, we know that the velocity has to equal 0. You need to be very careful with parametric equations and for vectors that you actually set both of these equal to 0, because they're not these, but they're derivatives. We know that the velocity has two parts. It has the dx/dt component, the x component of the velocity, and then the y component of the velocity. If this, case number 1, if dx/dt equals 0, that means the particle can't move to the left or to the right. But if dy/dt is not equal to 0, while it can't move left or right, it can move up and down. If you switch those, so dx/dt doesn't equal 0 and dy/dt does equal 0, then the particle can't move up and down, but it can definitely move left and right. So the key is that both of these have to be set equal to 0, or both have to be 0. So the first thing you would do is look at dx/dt, and we'll take the derivative of x, so that's a 6t squared minus 30t plus 36. Our dy/dt, the derivative of our y, is 3t squared minus 6t. We'll set each of these equal to 0. For this first equation, we'll factor out a 6. We're left with t squared minus 5t plus 6. So that's 6 times t minus 2 and t minus 3. So our t values are 2 and 3. For this equation, when we set it equal to 0, our common factor is actually a 3t. We'll pull out a 3t and we're left with a t minus 2. So t equals 0 and 2. So what we're looking for is a t value in common. At t equals 3, dx/dt equals 0, but dy/dt does not. And at t equals 0, dy/dt equals 0, but dx/dt does not. So the t value in common is t equals 2. So we know that the only time the particle is at rest is when t equals 2.